So we have logistic robots already now in, for example, hospitals. These robots avoid the interaction with humans. If we are able to get into an interaction with humans, we can solve more tasks than just transporting things from A to B. The goal of the project was to develop an interactive logistic robot. At the very beginning of the project, we didn't have a robot. What we had was we had three use cases: a logistic use case, guiding, and the delivery of beverages. And our task was first to develop a robot that could solve these three use cases.
Would you like something to drink?
Sure.
In the first phase of the project, we actually designed this robot. And we did this in an interactive process where we came up with ideas, we analyzed the use cases, we came with suggestions, we went back to the elderly care home, got feedback there. And in this process, we developed three ideas for robots, and we then picked one of them. And after approximately 9 months, we had the design of the robot ready. Then the company Robotize built the robot. And then in parallel, we developed software. And then we brought the robot in action in these three different use cases.
The design for the Smooth robot have been an iterative process. It has involved doing several observations at an elderly care center in Køge. We have involved both the elderly and the caregivers at the care centers to ensure that we take the user's input into the design process. We have involved experts in ethics and philosophy to ensure that human values have been part of the design process. The actual physical design of the robot has been a joint contribution by the consortium, simply just doing several different iterations to figure out what type of robot could solve the use cases best.
You are probably thirsty. Please take a drink.
I think there are some distinguishing features with our Smooth robot. One feature is that it can use different kind of modules to solve different kind of tasks. This makes it possible that a company or institution buys one robot and then buys some add-on modules to a much cheaper price, and so that the robot can actually work longer times because it can solve more tasks in an institution. The other advantage is that our robot has a very good balance in the use of anthropomorphic features, so that on the one hand it is distinguishable as a machine, but on the other hand it has some kind of cuteness so that people like actually to get in interaction.
Hello.
Some people put power, you.
Have a lovely day.
The robot consists of two cameras in the lower levels of the robot that we use to detect objects. The robot consists of 4 cameras in the head of the robot that is used for detecting humans and doing human-robot interaction. The robot consists of microphones and speakers, and the robot consists of 2 processing units, where one of them is focused on image processing.
Another distinguishing feature is that it actually can be built to a rather affordable price. And of course, there's a lot of software now to actually design behaviors so that a satisfying human-robot interaction is possible. For example, we can use gaze for indicating that we want to communicate with the human, or we can understand the gaze of the human to see whether the human is attending to me as a robot. So therefore it makes a lot of sense to use anthropomorphic features, because you can facilitate communication.
Hi there.
At the end of the Smooth project, we don't have a product yet. We are on a technical readiness level 5 to 6, while a product is on a technical readiness level 9. But I believe that in 2 to 3 years, we are able to be at a position that such a robot can be offered as a product. What I expect, it will be some kind of an evolutionary process where step by step, logistic robots will solve more and more tasks and become more and more visible in the public domain.